Welcome to my channel. Today we are going to solve the problem related with the realization of IIR system. So in the previous video, we discussed what are the different methods of realization of the IIR system. Okay, so in a detailed manner we discussed. So now we are going to solve the problem related with one. Okay, this question. So you see, uptime the direct form 1, 2, and cascade form realization of the following system function y of n equal to 0.1 y of n minus 1 plus 0.2 y of n minus 2 plus 3 into x of n plus 3.6 x of n minus 1 plus 0.6 x of n minus 2. Okay, so this question is a December 2017 and 2011, 2010. Okay, so three times the same question is appearing in the exam. So here, what is a given thing? The given equation is a time domain system equation. So here you see what is y of n, present output. What is y of n minus 1? Previous output. Y of n minus 2 is also previous output. This is the one time delay. This is the two time delayed output. Then x of n is the input. X of n minus 1 is the previous input. X of n minus 2 is also previous input. Okay. So here the present output depends upon the previous output as well as in present input as well as the previous input. So that's why this is called as a IIR system. Okay, so we are going to realize, we are going to draw the three different form: direct form 1, direct form 2, and cascade form realization of this system. Okay, so already you know the general structure of direct form 1, direct form 2 thing. Okay, so in order to realize the system in direct form 1 and 2, first we have to find out the h of z. Okay, so after calculating the h of z, we have to find the coefficient b0, b1, b2, etc. Similarly, a1, a2, etc. we have to find and just substitute that value in our general diagram, means that is our direct form 1 diagram and 2 diagram. Okay, so we will see. So first one, so you see, given that the given equation, you just write. Then in order to convert this time domain into Z domain, first we have to take Z transform of the above equation. So if you are taking Z transform for the above equation, what is the Z transform of the y of small y of n? It is a capital Y of Z. Then this 0.1 is a constant. You keep what is the Z transform of y of n minus 1? Z power minus 1 into y of z. Okay, then plus 0.2 into what is the Z transform of y of n minus 2? Z power minus 2 into y of z. Similarly, plus 3 into what is the Z transform of x of n? Capital X of z. Then Z transform of x of n minus 1 is Z power minus 1 into x of z. Similarly, here Z power minus 2 into x of z. Okay, so this is the first step. So this first step is a very important. So if you did mistake in the first step, means automatically that error is propagating throughout the problem. So the entire problem is wrong. Okay, so you careful about this first step. So you just take the Z transform of the above equation. So you see y of n minus 1 means the Z transform is Z power that amount of delay 1 minus 1 into capital Y of Z. That's all. So after taking the Z transform, so here you see in left side y of z term is there, in right side y of z is also there, x of z term is also there. So you just change this y of z term, you give it to the left side. Okay, then you take y of z as a common. So we can write 1 minus 0.1 z inverse minus 0.2 z power minus 2. Similarly, taking the x of z from this last three term, we have the x of z into 3 plus 3.6 z inverse plus 0.6 z power minus 2. Okay, then from this, if you are rearranging, the h of z equal to y divided by x. So 3 plus this one divided by this one. So this is the transfer function of our given system. So you just consider this is the equation number 1. Okay, so first one, so we have to realize in direct form 1 structure. Okay, so in order to realize in direct form 1 structure, first we have to find out the coefficient b0, b1, b2, a1, a2, we have to find out. Okay, so in order to find out the b0, b1, b2, a1, a2 value, So already we are having the standard H of Z equation. Okay, so what is the standard form of the transfer function of IR system? The H of Z equal to B naught plus B1 Z inverse plus B2 Z power minus 2 etc. up to Bm Z power minus M divided by 1 plus A1 Z inverse plus A2 Z power minus 2 etc. Okay, so let us compare these two our H of Z equation with the standard H of Z equation. So you just compare it. So in the numerator, you see the first one is a constant. So this constant is nothing but the B naught. Okay, so comparing these two equations, we get B naught coefficient is 3. Okay, and you compare the Z inverse coefficient. So what is the Z inverse coefficient in the numerator? 3.6. So here B1. So the value of B1 is 3.6. Similarly, the Z power minus 2 coefficient is 0.6. So B2 is 0.6. So after comparing these two equations, you just write B naught is 3, B1 is 3.6, B2 is zero point 0.6. Okay. So after that, there is no Z power minus 3 term, minus 4 term, etc. So that's why the B3, B4, etc. value is 0. Okay. Only these three coefficients. Similarly, you just compare the denominator part. Okay. Denominator. What is the first denominator? 1. So here also 1. Then what is the next thing? The next thing is Z inverse, the coefficient of Z inverse. What is A1? So here what is the coefficient of Z inverse? Minus 0.1. So from this A1 value is minus 0.1. Similarly here you see Z power minus 2 coefficient. Which one? Minus 0.2. So here A2. So the A2 is minus 0.2. Then after that there is no Z power minus 3 term, minus 4 term, etc. So that's why the A3, A4 value, all values are 0. Okay, so these are all our filter coefficients. Okay, this is B0, B1, B2, A1, A2. Okay, so this is our filter coefficient. So next one is after calculating this filter coefficient, we have to draw the direct form 1 diagram. So already we discussed in the previous video. So which one is the direct form 1 diagram, 2 diagram we discussed in the previous video. So you see this is the general form of a direct form 1 diagram. So in that direct form 1 diagram, you just substitute the B0, B1, B2 value. So in our problem, what all the value came? B0 is there, B1 is there, B2 is there. After that, the B3, B4 values are 0. Okay, so these, so up to this only the diagram will come. Similarly here, A1 is there, A2 is there, not A3, A4 is there. So this diagram, it can be eliminated. Okay, so you just draw this one up to this part. And here you see, so here there is any need of adder here. Okay, adder means we have to give at least 2 input. Okay, so that is after this line, there is no elements are coming. So that's why no need of this adder also. Okay, so directly this value, multiplied value is given to this adder. Similarly, this adder, no need. Okay, so except this, we have to draw the diagram and we have to substitute the B0, B1 values. Okay, so you see here, so we have to remember that direct form 1 general diagram. So in the diagram, this is the thing. Okay, so we have to substitute the value. So what is the value of B0? The B0 is 3. Okay, what is the value of B1? B1 is 3.6 and B2 is 0.6. Okay, this multiplier, the scalar multiplier value, you just substitute. Similarly here, the value of A1 is minus 0.1. Value of A2 is minus 0.2. So in our diagram, there is a minus A1. So minus A1 means, so minus of minus 0.1, it is 0.1. Similarly, minus of minus 0.2, it is converted to 0.2. Okay, so this diagram is a direct form 1 diagram. Okay, similarly, we have to draw the direct form 2 diagram. So already you know the general diagram of direct form 2. Okay, so which one is a direct form 2 diagram? So you see this is the direct form 2. So in this direct form 2, in center, the delay element will come. In first and last, the adder will come. Okay, so this half coefficients are minus A1, minus A2. Here B0, B1, B2. Okay, so here only the B0, B1, B2, A1, A2 only appearing here. So after that, no element will come. Okay, you just discard it. So that's why the diagram, the direct form 2 realization is, so you just draw, okay, this is direct form 1. So in direct form 2, this to delay is used by the single delay in a center. Okay, in center delay element, first and last adder. Okay, So in the first half, we have to use minus A1 minus A2. In the second half, we have to use B0, B1, B2. Okay, so you just substitute the values. So B0 is 3, B1 is 3.6, B2 is 0.6, minus A1. A1 value is minus 0.1. So minus of minus 0.1, 0.1. Similarly, here 0.2. So this is the input, this is the output. So this is the direct form to realization. Okay, then the third one, we are going to realize the given system in cascade form. Okay, so what is mean by cascade form? So already you know in cascade form realization, that is the higher order systems can be splitted into the multiplication of the single order systems. Okay, so already we discussed in the previous video the given h of z. Okay, so you see in cascade form realization, the transfer function h of z can be splitted as a product of number of first order section. That is the h of z can be splitted as h1 into h2 into etc. And in the next step, each h1, h2 we have to realize separately in direct form too. And finally, we have to connect all diagram in cascade. Okay, like this. Okay, this is the thing. So now for this problem, we are having the h of z. Okay, this is our h of z. So in this h of z, so what is the numerator higher order? The numerator order is 2. Okay, the z power, the higher order is 2. So it's a second order system. So the second order system, we have to split into two single order system like this. Okay, so you see the h of z can be splitted as multiplication of two single order system h1 into h2. So we have to split like this. So in order to split like this, so first we have to factorize this numerator polynomial and denominator polynomial. So first here you see here the z is in the power of negative. Okay, z power minus 1, z power minus 2 is that. So in order to factorize, if the z power is positive means it is easy for us. Okay, so that's why you just convert this h of z from negative z power into positive z power. So that's why I am multiplying both the numerator and the denominator of this h of z by z squared. Okay, so if we are multiplying numerator and denominator by z squared means, so we will get the h of z is equal to, you just multiply, so 3 into z squared. Okay, each term multiplied with z squared. So 3 into z squared, 3z squared, 3.6 into z inverse into z squared. So z plus 0.6 z power minus 2 z squared cancel, divided by 1 into z squared minus 0.1 into z, then minus 0.2. Okay, then next one we have to factorize the numerator polynomial separately, denominator separately. Okay, so if you are factorizing, so using calci or otherwise this is second order equation, so you just find the root using the formula minus b plus or minus square root of b squared minus 4ac divided by 2a. So if we are factorizing the numerator, we will get 3 z plus 0.2 into z plus 1. Similarly here, z minus 0.5, z plus 4. Okay, so you just split like this. So after splitting, okay, then so we want the h of z in z power minus term in order to realize. Okay, but here all z's are, that is positive z. So that's why again in reverse you just convert into negative z. So in order to convert into negative z from each term, okay, from each term I will take z as a common. So in z plus 0.2 I am taking z as a common. So if you are taking z as a common, what is the thing? 1 plus 0.2 z inverse. Similarly, from this term, you take z as a common. So 1 plus z inverse. Similarly, here you just take z as a common, z into 1 minus 0.5 z inverse. So similarly, here you take z as a common, this one. So then this z cancel and this z cancel. So now we have the 4 answers. Okay, so from this, you just consider the first part, the 1 plus 0.2 z inverse by 1 minus 0.5 z inverse. This is the h1 of z, and this part is said to be the h2 of z. So here you see this is the first order system, and this is also a first order system. So the second order system h of z can be splitted as multiplication of two first order systems. Okay, this is the step number 1 in cascade form. So first we have to write the total h of z as the product of single order system. This is the first step. And the second step is to, we have to realize the h1 of z separately in direct form 2, h2 of z separately in direct form 2. Okay, so where what is h1 of z? This is the one, 1 plus 0.2 z inverse by 1 minus 0.5 z inverse. Which one is h2? 1 plus z inverse by 1 plus 0.4 z inverse. So if we want to draw the direct form 2 diagram for this h1 of z, so already know the method. Okay, you just compare this h1 of z with the standard h of z equation. So what is the standard h of z? B naught plus B1 z inverse plus B2 etc. divided by 1 plus A1 z inverse etc. So here only in the single order system. So that's why no need to write B2, A2 etc. Okay, single order means up to B1 only it will come. So you just compare these two transfer function. So if you are comparing these two transfer functions, so you see in the numerator in the place of constant, what is the term available? 1. So the B naught is 1 and the coefficient of z inverse 0.2, this is b1, so b1 is 0.2. Okay, similarly you see the denominator, first one is 1, the second term a1, in the place of a1 there is a 0.5, so the a1 is 0.5. Okay, you just calculated, then you just draw the direct form 2 diagram. Okay, so in this this is the first order system, that's why only one delay element it will come. If you are coming to delay element means it is a second order system. So this is the first order system. So already know the direct form 2 diagram general structure. So this is the direct form 2 diagram. So in that you just replace the values. Okay, this is minus a1. So a1 is minus 0.5. So minus of minus 0.5 plus 0.5. Similarly here b naught is 1 and b1 is 0.2. Okay, so this is the diagram for h1 of z. So that's why the input I mentioned as a x1 of z, the output I mentioned as a y1 of z. Okay, since this is the half of the diagram. Okay, this is not a complete diagram of our system. This is the realization of the first h1 of z. So that's why you input you just consider x1, output you just consider as a y1. Similarly, we have to realize the h2 of z using this direct form 2. Okay, using the same method. So you see this is the h2. So you just compare this h2 with the standard h of z. So the b naught value, you see the b naught is 1 and the b1 is also 1 and in denominator you see the a1 is 0.4. Okay, then similarly you draw the same direct form 2 diagram and you just change the values, the coefficient b naught, b1, a1 value you just change. Okay, this is the realization of h2. This is the step number 2 in cascade. Okay, what is the first step? The first step is the h of z you can split as a product of h1 into h2. This is the first step. The second step is we have to realize the h1 of z in direct form 2 and the h2 of z in direct form 2. This is the step number 2. And the third step, you just connect the h1 of z and the h2 of z in cascade. Okay, which one is the cascade? So in order to connect in cascade, so first you draw, okay, first you draw the h1 of z diagram. So you see this diagram, this h1 diagram, you just draw first. Okay, then then this h2 diagram, okay, this h2 diagram you draw in a second. So the output of the first system is given as a input to second system. You just connect like this, that's all. The output of the first system you connect with the second input, and the input to the first system you have to mention as capital X of Z, and output obtained from the second system is our original output Y of Z. So this is said to be the cascade form realization of this H of Z. Okay, so this is the thing about this one. So this 3 question, it's a 16 mark question. Okay, 16 mark and 13 mark question. So obtain direct form 1, 2, cascade form realization. Okay, so what does the thing means? First we have to find H of Z. Then we have to compare this H of Z with the standard H of Z of our IIR system. So from that we have to find out B naught, B1, B2 value, A naught, A1, A naught, A1, A2, A3 value. Then we have to substitute this coefficient in our standard direct form 1 diagram. In 2 diagram means we will get the diagram. Then if we want to implement in cascade means first the H of Z can be splitted as product of single order transfer function. Then each single order transfer function can be realized using direct form 2. And finally, these two diagrams are connected in cascade. Okay, cascade means, so you see the output of the first system, this y1 is connected with the x2. Okay, these two lines are joined, means this combined diagram is called as a cascade form realization. Okay, so that's all. So in the next video, so this cascade form realization, so we will discuss one more problem we will discuss in the next video. This is also one of the university problem. Okay, so in a detailed manner we will discuss. Okay, so thanks for watching my channel, and please subscribe my channel for more videos. Thank you.